Let's go through an example problem for combination circuits. We have a combination circuit here where we have resistor R1 and R5 are in series with the battery here. And then we have resistors R2, R3, and R4 are in parallel. So the values that we're given are that the battery voltage is 36 volts. These are already actually put into the table. The first resistor is 10 ohms, R2 is 60 ohms, R3 is 36 ohms, R4 is 15 ohms, and R5 is 5 ohms. Now, a few things we want to look at first is we know that R1 and R5, and that's these guys right here, R1 and R5. Those are in series with the battery. So that means that they have to have the same current. So coming over to our table here, we know that R1 and R5 and the total or the battery current, all of those have to have the same value. And that's key right here is that those three, as soon as you get one of those boxes that I just highlighted, as soon as you get a value for one of them, you have a value for the other ones. And that's really important. The other thing is that when we look at the voltage, we know that the voltage drops across R2, R3, and R4, which is all of the ones that are over here in parallel with each other. Those have to have the same voltage drop. So once we get one of the voltages for the parallel portion, then we have the other voltages. So that means R2, R3, and R4, these voltages in here, once you get one of those values, you have all of the other values. So that's, again, key as we go through. That should help things out. And also remember, when we look at things in this table, as soon as you get two numbers across the table, you should be able to figure out what the third one is, because we know that Ohm's law tells us that V equals IR. This is kind of in a weird order up here, but we know that this column times this column should equal the column in the middle. So the first thing we're going to do is we're going to figure out what is the equivalent resistance that we're going to see for the parallel portion. So we're going to come in and simplify the parallel portion. So what we do is we take these parts right here and we find the parallel resistance. And that's going to be that parallel resistance, I'm going to call it RP, is going to be equal to the inverse of each of the resistors. So 60 to the negative 1, or 1 over 60, plus 36 to the negative 1, or 1 over 36, plus 15 to the negative 1, or 1 over 15, and all of that to the negative 1. If we plug that right into our calculator, it's going to fall out as being 9. I did this earlier. So 9 ohms. What that means is that we could take that entire portion, this portion right in here, and we could replace it with one 9 ohm resistor. Let me sketch out what that would look like. So we'd have our 36 volt battery. We'd have this 10 ohm resistor up here, which is what we had before. But instead of all those 3 parallel resistors, we're going to replace it with a 9 ohm resistor. And then this is still 5 ohms. So we've simplified the circuit, and instead of those 3 in parallel, we've replaced them with 9 ohms. Then we can take and figure out what the total resistance is, because now these 3 resistors are in series with each other. And so that is going to be that RT is going to be equal to the sum of the resistors, because they're in series with each other, 10 plus 9 plus 5, which comes out to be 24 ohms. So we can come over and put that in our table over here. 24 ohms over on our table. Right there. And then we have two numbers in the table along the total. So we know that we should be able to take voltage equals current times resistance. And we know that 36 is going to be equal to our current times 24. So taking the numbers right from here, we should be able to find this number right here. And if you divide 36 by 24, you're going to come up with 1.5. Got a little bit smaller there. Okay, so now that's highlighted. We know that that's our total current, and that's the current going through. I'm going to erase a little bit of this over here to help us. I'm going to even erase all of this. That means that the current that's in this area in here, the part that's not in parallel, all of that is going to be 1.5. So we can go and say that the current through R1 is 1.5 and the current through R5 is 1.5 because they are in series, in the series portion. And then this opens up a little bit more that we can do, because now if we look at this value, or this the second line of our table here, we have two of the values. So we can use Ohm's law to figure out what the third value is. So we're going to say that if we know, I'll just arrow down here, we know V equals IR, so that's going to be equal to 1.5 times 10, which gives us 15. And then for R5 here, for this last row, we also have two numbers there that we can use. So we're going to say that here V equals IR, and that's going to be V equals 1.5 times 5, and that should give us 7.5. Okay, now we have to figure out, this can be a point where people might get a little bit stuck and not know where to go next. And so there's a couple of ways that you can do it. The first thing is that if we go back over to our picture right here, if we realize that we start with 36 volts at the battery, and we know we're going to lose 15 volts at R1. Let me write that out here. Lose 15 volts here. And we have 36 volts here. And we know we're going to lose 7.5 volts over here at R5. Should just get a fatter pen, but that means that if the current starts with 36 volts, it loses 15 to R1, loses 7.5 to R5. The rest of the voltage is either going to go to R2, R3, or R4, because the current is either going to come through here and go through R2 and go back to the battery, or it's going to start out at the battery and go through R1 and then R3 and back to the battery, or it's going to start out at the battery, go through R1 and then go through R4 and go back to the battery. So if we take and subtract the voltages out, we can say that if we took 36, let me do it up here. If we do, I'll just write parallel voltage. If we take 36 volts minus 15 volts minus 7.5 volts, we're going to get 13.5 volts. And that means that each one of these is going to be 13.5. So notice that if I add them up, it's not that all of the voltage drops add up to be 36. It's the voltage drops through the series portion plus one of the parallel portions adds up to be the battery voltage, or 36. There is another way to do that, to figure out that 13.5, and that's to go over to this part down here and look at the fact that our equivalent resistance for our for the parallel portion was the 9 ohms right there. And so if we use the 1.5 amps that's coming through here, we have 1.5 amps that goes through the series portion. So if we know that I is 1.5, I equals 1.5 amps, and we use the parallel equivalent portion for R is equal to 9 ohms, then we can use V equals IR and do 1.5 times 9, and we can get, that comes out to also be 13.5 volts. I think actually it's easier to subtract out. Either way, you're still going to get 13.5. There's 2 different ways to go about it, and you can do whichever one that you want. And then finally, we're just going to finish up. Now we have 2 numbers for each one of these. So if we look at our 2, we know that we know that V equals IR, so it's 13.5 equals I times 60. I should probably use a different color or something like that. And then if you solve for that, you get a current that's very small, 0.225. Let's see if I can find a different color here to use. Do the same thing here for R3. So for R3, we have 13.5 equals I times 36. And that's going to give us a current of 0.375. And then finally, for R4, do that over here. R4, we have that 13.5 equals I times 15, and that would come out with a current of 0.9 amps. And one thing I want you to notice here is that if we take these 3 values right here, they should add up to be 1.5. So if we take 0.225, 0.375, and 0.9, it should add up to be 1.5, and in fact it does. If you go and you check that, you can see that they add up. So a few checks here. I'm going to go ahead and actually erase most of this so that we can just look at the pattern a little bit easier. We can see here again that if we take these 3 values here, they add up to be 1.5, and that happens. And if we're looking at the voltage here, we take that 15, that 7.5, and then add it to 13.5. One of those other values, any one of those, that should add up to be the 36, which in fact it does.